project is entitled Foundations for Superscalar Processor Architecture. And so the main part that I'm exploring is inserting queues between the pipeline stages such that it improves performance. So I've done some preliminary studies over here, and it shows that on this sequence of instructions, given that there's a cache miss here, some of the instructions can go into a queue instead of stalling in the previous stage. And this has, as seen here, you can see it's 3 cycles. So I expect that on a broader group of programs, there will be more cycles. More cycles can be saved. Yeah, so I'm currently working on implementing this queue control. So what I've completed so far is this testing framework. So the testing framework enables an iVerilog simulation to communicate directly with the FPGA. Then that makes testing easier, and then I also don't have to modify the DUT for the FPGA. The device under test remains the same and it's just directly synthesized. So the framework changes between the FPGA and in a simulation framework. And because of that, it allows reuse of tests and reduces modification, and so I can reliably test the device under test before putting it in the FPGA.
Okay, so we basically developed C3PO and R2D2 as embedded systems projects. C3PO is mostly motor control. He's running on a lot of closed loop systems based on an atom board. So the atom board controls all the motors. He can actually wave, his head actually connects to an Oculus Rift, and as the Oculus moves around when you wear it, his head will actually move with you, and you can look out of his eyes basically. He's running about 10 servos. So this hand will actually lift up, it'll wave at you, it'll shake your hand. The other hand over here it'll attempt to write what you draw in a MATLAB script. So this is all running off of servos. His shoulders have two closed loop motors on them. You can see the head is also actuated on 3 X, Y, and Z servos. So that moves with the Oculus Rift that it's connected to. And obviously this very large walking mechanism was designed by the mechanical engineering team, and it allows him to basically take a step as the 25-pound weight shifts back and forth inside his chest, which lets him balance. We do have R2D2 running around, and he's a lot more sensor-based. So he's got a LiDAR, some rangefinders, ultrasonic sensors on it. There's actually a Kinect inside his head, and the head can actually spin around, and he can kind of figure out where he is. He moves around, he can do obstacle detection. In the back of him, he actually has a bunch of tools that basically figure out what tools are in him. He's kind of like a moving tool chest. So you can actually tap an RFID card and kind of take out a tool, and he'll know who you are and where you are in the lab and things like that. And yeah, this was all basically for the Cornell Cup competition down in Disney. So we developed these systems to pass them on to other teams to use.
Our project is smartphone-based 3D occupancy tracking. So our goal is to create an integrated system for real-time tracking of occupants movement inside this building and to control lighting system dynamically based on users' location. We have an Android application that can scan for Wi-Fi access points and send the information to the server, so the server can calculate the user's position using weight-centered algorithms.
So that's the brief description of our project. The final purpose of the project is to check the users and then adjust the HVAC and lighting systems dynamically to save energy. It's like if the system detects that there is not anyone in this room, HVAC control system will automatically turn the lights and the room off, as well as the air conditioning system. So the final purpose is to save the energy. I think it's very useful.